Roger, I have a question for you here. For estimated process, is there a way to test how well the estimate matches the data, similar to distribution fit test for random variables?
No, there really isn't. So there are different ways that one does that, and it depends slightly on application, what's judged a good such test. And this kind of comes back to the idea of modeling. You build a model from data, and the question is, what's the purpose of the model? That's the kind of test that you want to run on your model. So, for instance, here are two common ways in which that's done. One is that, for instance, for time series models, a common thing to do is to look at what's called the residuals. And that means that, your best one-step predictor, that forecasting thing I did, your best one-step predictor is sort of everything that you know in the process, and everything that's left over should be just white noise. So that means that you look at correlation of those residuals, and they should behave like white noise. And so there are plenty of examples that showcase this in our application scenarios and so on. Another way, depending on what good is, what the purpose is of the model, is that you might look at these slice distributions. So the question is in fact my process producing slice distributions that are similar to the data I gathered? And you can look at any number of weaker tests, like are the moments roughly the same and so on, in which case you can go back to moment test. We expect to add more, but right now in my presentation I had a general sort of framework, and then we dove into sort of more specific domains. And the culture and what's considered the norm in these different domains just varies a lot. We expect that we'll have some more general level tests for processes in the future release.
Another question from a viewer: can one define a discrete random process not in the list that you were showing? Example, a beta process.
Right. Okay, so when it came to what we produced for random variables or distributions in version 8, we have a variety of mechanisms to extend that formalism. Now, we don't have a similar level of extensibility for random processes yet, but on the other hand, we have many groups of processes that are fairly general. So for instance, these Ito processes and its best friend in the life, which is called the Stratonovich process, those accept general systems of differential equations, and they also accept general sort of Ito and Stratonovich driving processes. So these allow for a sort of great deal of extensibility. And also many others are very general, like the Qs that we showed. You can use general distributions. But there are other things that I would like us to supply, for instance, to be able to transform a process that we have. And we expect to provide more mechanisms to achieve that in the future. And if you guys have ideas of something that's high on your priority list that we should focus on, please let us know. That's actually very important for us.
No, and that's something that we've been talking about a lot, is your feedback does mean a lot to us. And a lot of these features and a lot of these new functions have come from users wanting it, and that's how we know what to put in the next version of Mathematica and in more future versions as well. So the feedback is something that we do listen to and we do value a lot. So please, please, please provide feedback whenever you can.